What is the significance of the discharge process for the battery's energy storage capabilities, and how do the reactions at the anode and cathode work together to release energy? How does the design of the anode and cathode materials, hard carbon anode and NaMo2 cathode, influence the efficiency, capacity, and lifespan of an ion battery? How do these materials interact with sodium ions, and why is sodium chosen over other elements like lithium for these types of batteries? What are some of the key challenges or limitations in using hard carbon anodes and layered transition metal oxide cathodes in ion batteries, and how might these challenges be addressed in future research? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? Are there any notable advantages of using hard carbon, C6, anodes and NaMo2 cathodes over other material combinations in terms of cost, energy density, or environmental impact? What is the NaCO2 cathode, and how does it compare to LiCoO2 in terms of their use in Na-ion and Li-ion cells? What does it mean for the NaCO2 cathode to be initially in the discharged state when it enters the Na-ion cell, and how does the charging process affect the anode and cathode? What does it mean to activate the cell by charging it, and how does this process lead to the formation of the Na-intercalated anode and the Na-deintercalated cathode in the fully charged cell? What are the key differences in the charge and discharge voltage versus capacity curves of Li/Li1, XCOO2 and Na/Na1, XCOO2 half cells, and what do these curves reveal about the behavior of the Na-ion cell compared to the Li-ion cell? What does the stepwise voltage profile observed in the Na cell represent, and why do we see these stepwise changes in the voltage curve? How are these voltage profiles connected to the phase changes in the NaCO2 crystals during charge and discharge, and what happens when Na is deintercalated from NaCO2 to form Na1, XCOO2 during charge? What is the reverse process during discharge, and why does this result in the observed stepwise voltage behavior? How does the O3 crystal structure of both LiCoO2 and NaCoO2 contribute to their function in ion batteries, and what does it mean for the Co2 slabs to alternate between accommodating Li+ or Na+ ions? How does the C-axis of the A1, XCOO2 crystal where A equals Li or Na influence the behavior of these cathode materials? How does the crystal structure of NaCoO2 change during the first charge in a Na-ion battery, and what role does the removal of Na ions play in this transition? What does it mean for sodium ions to be stabilized at edge-shared octahedral sites within the MO6 octahedra in the O3 type phase, and how does this relate to the material's performance in the battery?